Okay, so if you see again, so that's what you can notice that. So you are able to replace, but address location is not changing. This concept is called as immutability. So after you understood this concept of immutability, there is one more concept called as copying. So what is the concept of copying? How we need to use? So there is something called as copy versus deep copy. This is the most commonly asked interview question. What do you mean by copying? How it can help us? If I have like number 1 is equal to 100 and number 2 is equal to say 200. If I say, hey, print number 1 comma number 2, so you get the values, everything is good. Now assume like not even like that, number 1 is equal to 100, and if I say number 2 is equal to number 1 I wrote. In this case, what will happen? If I say, hey, number 1 and address of number 1, if I say print, and similarly number 2 and address of number 2, if I do, what will happen? It will say both are something and fine. And for the number 2, if say now I am updating the value as some 256. Now after updating, means number 2 actually I created a copy, right? Using assignment. Assignment, I created the copy and I am now changing the value. If I change the value of number 2, will the number 1 change to from 100 to 256? No. So earlier when they are storing, they are at the same address. Whatever it stores, it doesn't matter. But did you see now, when you are changing the second value, the original is not changed, right? Original number one is not affected, right? That's what the point. Similarly, for the lists also, I will try like that. Let's say my list 1 I have is equal to 1 1 2 2 3 3 4 4. Very simple list. Now from this list, I want to create another list called as my list 2 is equal to my list 1. So copy using assignment, right? Assignment operation. If I do like this now, if I print like, hey, give me my list 1 comma address of my list 1. In the same fashion, my list 2 and address of my list 2. It's very simple for you to understand. Both are having same value, same address location. This is good. Now for my list 2, if I am changing, say instead of overwriting, let's say one of the value I'm changing. Say if I go to the second value and I am updating to 2. So modifying one will affect the other. See how it is affecting. I am again trying to print the both the things. See, same like integers, I try to do with a list. And if I see, did you see what happened? So even the original is also affected. Did you all understand what I'm trying to say? So by default, so whenever you take a copy, the original should not be affected, right? But here original is also getting affected. This is a copy problem. How to address this copy problem? So to address this copy problem, so there are two solutions, either copy and deep copy. So first thing foremost, so we can go for copy. So copy, how do you do? Let me take the same old things again and start working. This time I say my list 3. My list 3 is equal to same old thing 11, 22, 33, 44. And my list 4 is equal to my list 3 I am taking dot copy. So assigning a copy rather than original. You see now? Now if I say print of my list 3 comma ID of my list 3 and my list 4 ID of my list 4. Say I have these things. Now, did you understand? Did you see different address locations? Address locations were different. Now, if I try to change, say my list 3 or 4, say my list 4 is there. In that, I want to change the same third value I want to change. This time I want to change to say 3. And I want to print both the things. You see now what will happen? Did you see? So original is not affected, right? Original is not affected. So, and if let's say you are changing to the original, maybe like my list 3 is your original. So in that I want to take the second value and I want to update to 2. Now you see here. So in this case, you changed the original. Okay. So in the same thing, so copied is not affected. Did you see? You changed it to true. Only that was changed. Others is not changed, right? So this is how you do. So a copy is also called as copy or shallow copy or soft copy. Can be created in 2 ways. So 2 ways. One, using list.copy. This is one way. List.copy. This is one way. Or else there is a copy module. Copy.copy. Means I can do the same thing again. Import copy. Copy is a module. Copy. And I can start working. So if I say like, copy dot copy of say my list, so 1 and do it. So this time I do with one thing. So original list, original list is equal to again, say 1, 2, 3, 4. This time I took and copy list is equal to. So I sorry. So copy dot copy of so original list. Like that also I can take, or so original list dot copy. So both ways you can do. If I do like this also, so nothing will get problem. You see now, if I say like original list, comma, address of original list. Similarly, if I say print, so copy list, comma, ID of copy list. If I say, did you see different address locations? Nothing was affected. So if I say original list of say 1 is equal to, so original 1, if I say like, copy of list of same 1 is equal to, say if I write like, copy 1, if I do, now if you see both the things I changed, so nothing should affect the other one. You see, so original got changes to only original, copy dot changes to only copy. This is also good. Now let me do the same thing in another way. The same thing I created, right? For this list, for a small change, I am trying to do one more thing. Means I am recreating. So instead of like 1 dimension, I am going for 2 dimension. Say like to make it easy for you, 5, 6 I have. So again, this same 2 created. I have the values, and this time I want to change original list of say 0, 1, 2, 3, 4. If I print fourth value, what will I get? The entire thing, right? In that, if I want to get the second value, I need to index start from 0. So like this I got. And this I say, I want to change like original 6, I want to say. In the same fashion, in the copy list also will be there, right? Copy list also I have. Copy list I want to do. Is it clear how it's working? Both the things I changed, but inner values I changed this time. Now, if you see right now, did you see what happened? Whatever the changes you do on one of them will affect the other. Let me show. So both are affected. So both are affected. Why, sir? Till now it didn't affect, right? Means copy or shallow copy will not do for more than one dimension. So solution is use deep copy. Means whenever you're creating the things, so instead of that, you need to create like this. So means like I recreate again. So instead of copy, I use like deep copy. This is like most asked interview question because that was its impact. If I do create, same like the others, here also two different data types were created, everything is fine. Now, if you do the changes and you can observe the difference, you see, did you see nothing was affected, right? Was affected. Any to take any inner dimensions also you can. So what's the conclusion? So soft copy is faster. So whereas deep copy is slower. So whenever you want to have a single dimension, go for a soft copy. When you have multiple dimension, go for deep copy. Is it clear? So this is the most important thing whenever you are working. After going further, let me again go for this thing. You go for the attributes. You see, copy is one of the attribute you saw. So like that, if I go further on list attributes, you can notice that list has pretty good number of attributes. Say if I take a numbers equal to something, and you know DAR is a built-in function if you want to get the list of attributes. And this DAR will give the list of attributes based upon the data type. So if you see the list, you see it's a big list, right? So that's where DAR, whenever you're doing an interactive mode like Jupyter Notebook, I write a print so that everything will come crisply, in a single place. You saw, right? So if you, as we know that we ignore things which have underscores on either side, ignore them. So still we have these many attributes are there. So I told you why we ignore these things which have underscores on either side multiple times. To say one last time, you can see here, length we can ask in two ways, right? Length is a built-in function or like underscore L. And I told assert is one statement. After writing assert, if you write anything, if it is wrong, it throws an exception, assertion error. If it is correct, it will not throw any error. So that itself is a true for you. So either way you can use, which or is better? Length built-in function, right? So that's why you go on the other way. Similarly, if I go for the string, either you can use string built-in function or underscore str. So both will give the same result. And similarly, if you want to do like, string repetition. So string repetition means like you want to take a string and you want to multiply with something. Generally, in most of the other languages, this will not be available. Means you cannot multiply a string with a number. So, but here you can multiply a string with a number. You see, you take a string, so like that, list repetition is there. So you take a list and you do into three, means the same list will come three times. After that, your original list is not changed. The same thing you can do with underscore mul also. Means even if you use an operator, indirectly it will use the same. But as a human beings, we prefer this one, right? That's what. And similarly, if you want to do like there is something called as underscore imul. Underscore imul is same like using the so multiply equal to operator. Hope you know multiply equal to operator, right? It will modify the changes. So same like that. So imul will modify it. Mul will not modify. So do the changes and also update to it. Whenever you use so this compound operator also, the same thing will be used. Hope you are clear about it. So now going further, I also showed you something about um, what do you say, concatenation, list concatenation. Same like the repetition operation, there is one more thing called as concatenation. If you have two lists, we can do that. Let's say I have, till now we have numbers, right? Numbers is equal to say 1, 2, 3, 4. Say I have alphabets is equal to say A, B, C, something. I can do two ways. So instead of every time printing, I'm just showing you straight away. Numbers plus alphabets is same as numbers dot underscore underscore add of alphabets. Both will do the same thing. But if you print one of them, you can see numbers plus alphabets will give a combination of the same thing together. Hope it's clear. That's how concatenation operator works. And similarly, so if you want to make the changes to be done, so there is another way called as underscore underscore I multiplication. So after doing this also, your original list will be the same. It will not change. Whereas if I do numbers dot I underscore so and so alphabets, this is same like numbers plus equal to alphabets. You see, after this, your original numbers is also changed. So that's a difference. Similarly, if you want to do a membership check, there are two ways of doing, either using underscore underscore contains or in operator. So both will do the same thing. For checking for presence of anything, you can use. Similarly, if you want to get the size of any object, this is very interesting. Let's say you have numbers dot underscore underscore size of. There is one attribute called as size of. If I give size of, I will get the total number of bytes involved. But there is one more thing if you can observe using sys module. If I import sys module, see indirectly we are using sys module for a lot of things, right? So if I say sys dot get size of, this is another thing for the numbers. For any object, there are two ways of getting the size. If I do like this, it is saying 136, here 156. So what do you think like the change is? Means you need to understand how Python works. Python is an interpreter. Means like it will convert to some base language. So the most common base language is C language. Hope you might have heard about C Python. Means from Python, it will convert to C language. So these numbers.size of will give the Python level size, whereas this get size of will give the size including the C header. Hope it's clear. Okay. Next thing. After this, not only this, for this strings also we can, sorry, not only like strings, even for these also we can ask something called as underscore underscore doc. Yeah, underscore underscore doc. So if I say underscore underscore doc, it is showing like this. If I do print, you can show built-in mutable sequence. So for the list also it is showing like this. Or if you want to get the help, if you do help of these numbers, you can get the entire help, right? So what are you have seen till now? It's an iterable. So what are is coming, your doc strings, what are is coming is like this. You might remember, right? You say underscore underscore add underscore contain, all these things you give. This is all about these things. Now going further, let me tell you that we can do a good number of things here. We have seen concatenation, repetition, and all these things. So one small assignment for you is about check whether list concatenation is commutative. So you check what do you mean by commutative property and how to execute that by next class. And list, I am saying like list addition is commutative. Addition and repetition, both you check it. Next, after doing all these things, we want to check the operators which don't have underscores on either side. So if I say print of dir of numbers, if I execute, I got a lot of things. Say I want to print only in things which don't have underscores on either side. Let's do for loop. Say each attribute in dir of numbers. So this is what we are doing, right? Print of each attribute. So don't you see you're doing the same thing every time? Now for a moment, I'm asking what are the data types of this? Oh, everything is a string. Now if it is a string, there is one interesting thing that we have. Every string, if you want to check whether it is starting with an underscores or not, we have an attribute, you remember? Dot starts with. If I give dot starts with an underscores, did you see? So for everything, either true or false, it is coming, right? Say if I want to print that first, you can better understand. You see now, when it's executing, every time it is saying true or false. Say only if it is true, I want to get. Means what? So this is how in real time we use anything. If I just print a value, it means that result should be true. That's what I'm expecting. Did you see you got what? Only things which have underscores on either side. But we don't want them, right? So I write a not. If I execute, did you see I got the attributes which don't have underscores on either side? Is it clear? Right? Okay. Now let's see. Again, I'm writing like my list sum 5 is equal to. So the beauty of this is that you can repeat the same numbers any number of times in any order or any values you can have. So it doesn't matter. So whatever you have, it will work like this. So for this string list, sorry, I want to ask different things. Dot count. Count is one of the attribute. Say for my list file, count of, say I want to get the count of 2. If I say count of 2, it is saying 2. Means 2 is present 2 times. Similarly, if I say my list 5 dot count of say 1, how it is saying? 1 is present 3 times, it is saying, right? So how many times? 1 here, 2, and third position. Observe carefully, very interesting this point. If I take these two into a list and do, see one of the one is in inner dimension now. If I execute again, let me take the same example. Print of f of 1. So let me take like this. Okay. So if I do like this, observe difference. For the 2, if I give, 2 is outside, but fine, you're getting the same numbers. Say like I take the same 2 inside also. Okay, now see, even if I have inside one more 2, it's not taking that. At the outer level, if it is having that value, only it is giving. Did you all understand? So if I do the same thing at one more level, say my list 5 of what is this inner dimension, how to go? This in terms of indentation, how, what is sorry, indexing? 0, 1, 2, 3, 4, 5, and the center is 6, right? So if I say dots of 6, dot count of 2, then you can see 1. Dot count of 1, then you can see this other. Hope you understood what is the importance of count, how we do. So I told about the count, copy, both the things I told. So then one more thing is about clear. So, and like these things, I'll tell you how it works. If I say my list is there, so my list 5 dot clear, if I say clear, so if I, after that, if I say what is my list 5, you get empty. But address location will be the same, but values will not be there. And if you just want to delete any object, you can do like this. It will entirely delete. After that, if I ask, hey, what is my list file? It says, I don't even know. That's why you should be very careful with the del symbol. Okay, coming back. So still we have good number of things. Let's see these attributes one after the other. So if I want to see one at a time, first I will focus on the most common things called as append, extend, and insert. These were like most common things asked: append, extend, and insert. So if you want to add any values to an existing list, this is how you do. How to do with that? Say like I have an my list is equal to 1, 2, 3. I have an empty list. So when you're creating a list, you have some values. After that, if you want to add, you can do like my list dot append of say 4. If I do append of 4, and after that if I ask, hey, what is my list, it's printing. Similarly, if I ask, hey, append of not only individual values, maybe like I will take a list and I print, so it will do it. Or this time I take the same append, but this time you see what I do, like a this is called as a tuple. So 6, 7, 8, something I give. Did you see? Means if I give like an individual value, it is taking but adding at the end. If I take like a list, it is taking but adding at the end. If I take like a tuple of 3 values, taking the values but adding at the end. Means whatever you give, it will take as it is, right? But it will add at the end. This is what you understood about append. Or not only this, so if I take the same thing and if I say 9, like a string I added, so that also it will add. But whatever you give, it is just adding at the end in whatever way you give. Now we see the same examples with the other one called as extend. For the same my list, I try to do extend. So now I got to do add 10, right? I do 10. What is saying? Int object is not iterable. Hope you remember this concept of iterables. Iterable means what I told. Object that supports for loop on itself. That is called as an iterable. That we understood. So what are those objects which support for loop on itself? So the examples are like, so the string is in one of the examples, and collections. All the collections means list, tuple, set, dictionary. Tuple, set, dict. After that, iterator. So next you will see about generator. So all these objects are there that you will see shortly. But for now, you don't know all of them. So we can start with my list dot extend of the same 10 if I pass like a list of a single value. Like a list, in a list, I pass like a single value. Now, after that, if I ask, hey, what is my list? Did you see what happened? It is now having the 10 in the, so at the end only, but in the same dimension. Observe one more thing I'll do. My list dot extend of, say like in a list only, say like 11, 12, 13 I give. And after that, if I do my list, means individual values it is not taking, right? Like int, float, all these things, if you give, it won't take. But if you give like a list or any iterable, it is taking. But did you see, in this case also it took, but it added to the same dimension. And if you see in the previous case, how it worked, when you added in the append, like in a list or anything, it is adding whatever you give as it is. It is not adding to the same dimension. So whatever you give as it is taking. But it is not taking individually. It is taking only triples extent, but it will add to the same dimension. Means like it will do a for loop on it and do an insert, so append operation in the backend, right? That's what I can say. So and similarly, if I go with the same thing, say my list dot extend of say after 10, 14, right? If I do like a string, and if I ask, hey, what is my list? Did you observe what happened? In 14, it took like all characters into like a single dimension. This is how Jupyter Notebook works. When the number of values are more enough for better showing, it will do like this. If you feel like not to do, you can use a print also. But like you can understand, right? What are the values till 13 are there? After 13, this 14 was taken. So don't you think 14 is a string? So it's like doing a for loop, getting one character at a time and inserting at the end. So now we understood the difference between append and extend. So append and extend both will add in the last, but append will add as it is, extend will add to the same dimension. That's a difference. So after learning these differences, let me take one more example after this conclusion. What if you want to add at the starting or in the middle? So append and extend will add, but not in the first. All it will add in the last. If I say like, my list again, I have a lot of values. Maybe like I want to insert somewhere at the some position. So before that, like I say, I want to short the list. That's the best thing, right? If I say my list of column say 10, means still 10 values I want to print. Instead of the all values, I want to print only 10 values. You see, I got only 10 values. Now I want to override this thing. My list is equal to my list. Removing some elements, removing a slice of elements. If I say my list, you see, now you see the my list. If you want, say, I can do my list and the ID of my list also for you to understand better. Say first ID and my list. You see now, initially address location, that address location is changed. So don't you think it's called as overwriting? Overwriting it. So this is different. This is not, so in place changes, it is overwriting. But you see, this is how I removed some of them. I don't want. So because for our convenience, it would be good. That's why I took like this. Now I will explain the concept of insert. Insert means if you give anything at a specific position, you can insert. If I say at the 0th position, if I want to insert, say 0. And if I say like print my list, did you see what happened? The value at the 0th position is not removed. They've all shifted their position by one position. So that's why instead of, values count will increase. And similarly, if I do the same thing and if I do an insert, so maybe like let's say give some number randomly, some 4th position I want to insert some 4 values, say 4 4 sorry 4 4 4 4 4, something I have 3 values I want to insert. Did you see at the 4th position this was inserted as it is? Means it is doing same like append, but in a whatever position you give. So what if you want to insert at the last position? So at the last position, say I want to insert like a last as a string. I want to insert. Did you see what happened? So it's not doing at the last. It is doing at the -1th position. So that's why there is an entry question. So how to work? So my list dot so insert. So if you want to work like list dot append, if you want to do, means append generally I do at the last, right? If you want to do, it's not -1, but you should give the length of my list and do. So maybe like this time I want to take, so give some number, something, say I want to take a tuple of something last. val something around. Now you see in this case, so what are the value it took? It placed in the last, right? So that's what I want to say. Similarly, there is a difference between substitution. There is one more thing called a substitution. So insert means what? At the specific position it is inserting, all the values after that will be removed. Whereas something called as substitution, which you did a lot of time till now, means like you are identifying some value like a third value, and you get something, and you are trying to overwrite it. So 3 is equal to some 333. This is called as like substitution. Substitution will change the existing value, whereas insert will what it will do? It will just move the values one side ahead. Nothing will be lost. So that's what you need to remember. So now we understood all these things. Now, finally, if you see your my list, you have some values. So from this, if you want to delete specific thing, so by position, by value. By value, if you want to remove, by value, there is something called as my list dot remove of, say, I want to make a small list for you to better understand. Say my list is equal to 1, 2, 1, so 3, 4, 3, some 3 is there. Okay. So by value, if you want to remove, there is something called as my list dot remove. For that, we need to give the value. Okay. If I do remove, and if I say, when I'm doing the remove operation, nothing will come. But if I say list, did you see what happened? So if the same one is occurring twice, the first occurrence. So from left to right will be removed. Now, an assignment for you. Check how to do from right to left, and remove. Check how to do right to left and remove some one of them. So remove, what it is doing? If the value is present, it is removing. What if the value is not present? Say if I am trying to remove something like a Q, which is not there, right? For remove, if you are asking for something, it should be present. If it is not present, it will throw an error. So whereas, what if you want to remove by a position? So there is something called as pop. For pop, if you give, it will remove the last value. Every time it will remove the last value. If I say my list dot pop again, it will remove the last value. Not only remove, pop is the only operation when it is doing also it will give the value. And if I say again the list, it's like this. And for pop, it's not just like the last value every time. We can remove any specific values. Means like if I take the same old previous thing, it's a big values, right? If I take like this, it's a like a big list. So I can remove anything specifically. Okay, say my list is equal to, I have this big list maybe. Okay, count down this big list. It's not that we can't do in multiple lines. Like this also you can do, just for you to understand. So if I want to do a pop, I want to remove the third position value. So it removed the third position value. And if you ask the list, so this 333 won't be there. Say if I want to remove this one now, what is the index? 0, 1, 2, 3. Again the third position value, right? So if I do like my list dot pop of third position, the beauty is that it will remove and also give the value at a one shot. So that's no more there, right? And say like, if I want to remove, say like my list dot pop of say some last value. If I want to remove, it gave the last value. If I want to remove the last value, so like this also I can do. So specifically for last value,